Hello, everyone, and welcome. My name is Amy Brown, and I'm the Director of Events and Education for FacilitiesNet and Trade Press Media Group. Thank you for joining us for today's webcast, Learning How to Perform a Gas Treasure Hunt at Your Facilities. Our presenters today are Mark Ditch, Senior Energy Manager with National Grid, and Michael Pace, Engineering Management with Leidos. Mark has 28 years of experience as an engineering consultant and construction supervisor in the HVAC and energy industry. Mark's provided commissioning services for new and remodeled mechanical, electrical, and energy management systems. Michael's been involved in energy efficiency for over 20 years in a variety of roles that include project management and implementation, utility program design and technical support, and management of energy service companies. Mr. Pace has a BS in engineering and an MS in facility management, both from the Massachusetts Maritime Academy. So now let's go over a few of today's learning objectives. We'll be reviewing technology and economics, learn how to optimize ventilation, discuss how to improve steam system efficiency, and talk about ways to upgrade boiler controls. We're in for a great treat today during the webcast. But before we get into the content, I'd like to start with just a few details. We do encourage audience questions throughout the webcast, and to submit your question, you can navigate to the Q&A button at the bottom of the screen and type in your questions. We'll be answering as many questions as time permits. At the conclusion of today's webcast, you'll also receive a PDF copy with the presentation slides. You'll also receive a link to a brief online assessment, and upon successful completion of that assessment, you'll receive your CEU certificate that you can use to self-report to any license or board. Today's webcast will also be archived at facilitiesnet.com/webcast. So if you want to review parts of it or send on to people that aren't on today's call, feel free to go to facilitiesnet.com/webcast. And with that, we'll start the content, and I'll turn it over to you, Mark.
Thank you, Amy. Good afternoon, everybody. So with National Grid meetings, we always start with a brief safety message. I felt that because of the time of the year, for obvious reasons, I would touch on carbon monoxide poisoning. And when I started to do a little research on it, I found it very interesting that the reason it takes place is the fact that carbon monoxide actually has a stronger affinity to attach to your hemoglobin or your blood molecules than oxygen molecules do. So it actually replaces them. 1/3 of all carbon monoxide deaths are a result of fireplaces, stoves, portable heaters, and vehicular exhausts. Of course, the next one this time of year is for portable generators for probably obvious reasons, although we don't need them in National Grid territory. So the symptoms, if they should occur, would be including headache, much like a tension headache, dizziness, confusion, nausea, and shortness of breath. So to prevent it, the best way is to make sure that you have a CO2 detector in your home. You would preferably want to have it hardwired, but within 20 feet of a potential source, which would be any fossil fuel burning appliance. And because it is slightly lighter than air, you want to have it between 5 feet, which is considered your breathing zone, and the ceiling. So please be careful out there, folks, when you're using these types of equipment. And with that, I'm going to pass the baton back over to Mike Pace, who's going to go over some technical considerations for treasure hunting.
Great. Thank you, Mark. Welcome again, everyone. We appreciate the opportunity to present this information to you today, and we're looking forward to some great questions coming our way. To echo Amy's comments earlier, don't be shy about asking questions, and I always like hard questions, so don't be shy about those as well. I typically start my presentations with talking about Ashrae Standards. Where have we been? Where are we going? And what is coming up next? And you can kind of see the trajectory here. This is Ashrae Standard 90.1 of code requirements for both site and source energy. you can see that trajectory really forcing all of us to become more efficient over time. And I only put in through 2016 here, but if I put in 2019, that would have an even lower bar graph here as well. So you can kind of see where things are going. We're all feeling that when we see our gas bills, gas prices are going up, and our opportunities for us to improve that efficiency are always going to be there or always will be there. So much of what we'll talk about today revolves around ways we can help you improve your gas energy efficiency and where to look for different opportunities within your facility. So some of the technologies we're going to talk about today, ventilation. Ventilation is a big thing that's on everyone's mind in the COVID world that we're living in. We'll talk about steam systems, improving of processes, and improving of controls. There's really a lot of great opportunities that have come on the market over the past number of years that you may not be aware of, and hopefully we'll be able to touch on a bunch of those today and give you some great takeaways as well. But there's some great opportunities to reduce your energy usage quite a bit with a variety of technologies we're going to talk about. So common sources of poor air quality that require you to manage that and improve ventilation. COVID obviously being the biggest discussion point or issue that most facility managers and building operating managers have to deal with. I remember when COVID first hit, I had a number of my customers call me up and say, Mike, I got to improve my ventilation. What do we do? And we kind of walked through some strategies and talked about different ways you can do that. And then, 2 months later, the question came up is, wow, my energy bill is just bonkers. And that's the unfortunate reality that everyone has to deal with, is managing indoor air quality, but doing so in a way that's the most efficient way that you can operate. Other things that require indoor air quality management, new furnishings. I had done work at a very big customer where they did a whole fit out of new furnishings for their office, pretty large office. And one of the things that they realized they needed to do was improve the ventilation because there was such a good amount of off-gassing coming from the new furnishing that it affected the folks that were working in the space. Same thing goes for construction materials and adhesives, ventilating those. It's really a big deal of great importance. And then also cleaners and chemicals as well. So indoor air quality has always been on folks' minds. In the COVID world we're living in, it's becoming even more so. And we'll talk about ways to do that in the most efficient way possible. Just as we had said, IAQ, indoor air quality, is a huge issue. COVID being a huge amount of that. But, as I saw in the first slide, our Ashrae code requirements have really improved the building shell. So that had the effect of windows are largely sealed. So there's not a lot of opportunity for folks to open windows much anymore in an office type building. So having good ventilation is absolutely critical. The third bullet point there, increased rates of childhood asthma. This is an interesting conundrum that's occurred, peaks and valleys over a number of years. I always go back to the example of the 1970s during the oil crisis. A lot of folks reduced their outdoor air ventilation in that time to kind of manage the impact of the increased oil costs and fossil fuel costs. And what that had effect over time was a reduction in outdoor air, but you had increases in childhood asthma, increases of poor indoor air quality. And then you saw kind of in the early 1990s, different types of strategies to manage ventilation, demand control ventilation, and the like to help do that. And what we have from the 1990s on today is a great ability to adapt our ventilation, excuse me, that's hard to say, in a way that allows us to do so in the most appropriate way, but in the most efficient way possible. And again, the last bullet point there, greater customer sensitivity to ventilation requirements is always an issue that building owners now have to really take great care in managing. I got this question, geez, it seems like once a month from different customers of mine is, hey, Mike, why don't we just let the buildings leak, right? Well, there's a good reason for that. Controlling ventilation is much better because you control it. It's conditioned. You're not just letting things leak in from the outside. You don't have any control over that, whether it's too hot or too cold. The ventilation air is filtered. You see a lot of folks using different types of filtration systems these days in response to COVID, different ultraviolet type systems. All good, but you have the ability to control that because you're not controlling the ventilation. Typically, the ventilation is distributed through the building relatively easily and relatively evenly. So that goes a great deal to making sure not just people that exist along the leaky windows get the ventilation, but the folks within the interior spaces of the building get equal amounts of fresh air as well. And again, today we have the great ability to control ventilation based on a variety of factors. You really can provide that only as you need it and in the amount required. So it's a great opportunity. I always tell folks, if you're looking at ventilation, it's a great opportunity to do so in the most efficient way possible, because there's so many different types of technologies in the marketplace now that allow you to do it with relative ease. My last real, or one of my last real Ashrae slides, I get the question a lot of, it seems like different Ashrae standards may be in conflict with each other. And the truth of the matter is they're not. Ashrae 62.1, it's really there to resolve indoor air quality problems. It does have the effect of increasing energy consumption for obvious reasons, right? If you're bringing in more outdoor air, you're going to increase the amount of energy you're using because you don't have to heat or cool that air. And 90.1 is really the standard used to reduce energy consumption to support energy efficiency. So they work hand in hand together. Sometimes folks think they're apple and oranges, but they do work hand in hand together, and they're both critical to ensure buildings operating in the most efficient way possible. All right, so now we're going to talk a bit about different types of energy recovery ventilation. And what does that mean? That means we're going to try to ventilate the space in the most efficient way possible by recovering some of that exhaust air and using that energy to preheat incoming fresh air. There's a variety of technologies in the marketplace that can accomplish that at a variety of different price points. And the good news is the efficiency of these technologies have improved over the years quite a bit. I was recently at a large bus terminal just outside of New York City, and they have an enormous amount of ventilation requirements, because you can imagine a big bus terminal, the buses are in the building getting warmed up for the day, and there's a lot of need to ventilate that byproducts of combustion, as Mark mentioned in his first slide. And they ventilate quite a bit, and they recover that ventilation through ERVs, energy recovery ventilators, wheel type ERVs. And the wheels are about 30 years old, 25, 30 years old. And they are in need of replacement. And the great news is they can replace them with extremely much more efficient wheels. And we'll get into that a bit later. So there's great opportunities if you do have an existing ERV system that might be a little dated. You can improve that, replace that with a much more efficient option. And as Mark will talk a little bit later, those would potentially be eligible for incentives from your local utility as well. So a basic simple design of what an ERV looks like. You're bringing in ventilation from the outdoor air. That outdoor air is being preheated from the exhaust air leaving the building. And like I said, there's a variety of ways or technologies that can accomplish that. And what that does, it has the net effect of not needing as much energy to heat or cool that outdoor air coming in. And also you do have some local exhaust as well that you'll see in typical buildings. But this is a pretty simple design of what a small building would look like or could look like if you wanted to put one in. And so, like I said, it's a great way to manage the effect of bringing in outdoor air, but doing so in the most efficient way possible. Real quick, typical types of heat recovery systems. Plate heat exchangers. This is an older technology. It's more of a, see mostly these days I see in the small commercial residential space. Pretty pretty good efficiency on a sensible side, 50 to 70% efficient. And then in the middle there, you have a heat pipe technology that's been around for quite a bit as well, typically in the commercial space, industrial space. The big item that we see a lot of customers either looking at or replacing or installing as new is heat wheel technology, because the efficiency, the total efficiency, both sensible and latent, is quite substantial. So I mentioned that bus terminal example earlier. They're in the plot process of replacing their 50% effective heat wheel from the 1990s to 78% effective heat wheels for today. So huge improvement in the efficiency of these types of systems. And these are very common in a commercial industrial space. As I mentioned earlier, air to plate heat exchangers, plate type heat exchangers. Smaller flow, there's not a lot of typical CFM, not a large amount of CFM flow through these systems, mostly in the residential space. Very common, very inexpensive, relatively easy to maintain, not a lot of moving parts, actually very, very little moving parts, and great way to manage ventilation efficiently. This is just a little bit of a powered version of that. Again, this is typical for a residential style, small commercial style space. You do have the fresh outdoor air being pulled into the building, but being preheated by the exhaust air going out. Great, simple technology, works great. The number of our customers that use this every day have had great success with it. I just put this in there just to talk about some of the applications that we see quite a bit of folks trying to do, mostly on the new construction or gut renovation space, where you have some sort of desiccant wheel and a DOAS unit. A DOAS is dedicated outdoor air system, and that's bringing in the fresh air into the space, recovering the exhaust heat, preheating that exhaust air with the incoming air. And then you may have some smaller supplemental rooftop units there to heat and cool the space, but the majority of the fresh air coming into the facility is run through that dedicated outdoor air system. So in closing on that slide, let me just go back to that one more second. I want to talk a bit, big key takeaways I want to leave you with is ventilation is on everyone's mind. Ventilating appropriately and efficiently is hugely important. And there's ways you can do that to accomplish your ventilation goals, but do so in the most efficient way possible, because that's really going to affect a variety of your needs quite a bit. Okay, now we're going to transition over into my favorite topic, the boiler and steam world. And we're going to talk a bit about ways you can improve the steam system efficiently. Systems efficiently. That's hard to say. There are quite a number of things that are hard to say. But this one here is boiler reset controls. And inevitably, I go into a number of big buildings that use steam or hot water for that matter every month. And I typically ask the customer, how do you control your boiler? And inevitably say, well, there's a box on the wall that's supposed to do something, and it's been doing that forever. And that box could be some type of reset controller, right? So that reset controller, whether it's steam or hot water, they kind of function the same way. It's taking the outdoor air temperature and it's measuring either the condensate return, in this example here, this is a steam system, or the hot water return. And it's measuring both of those values and making some iterative determination on how the boiler should operate. Typically, it's a reset curve, very simple, where as it gets warmer out during the heating season, the boiler operates less. And as it gets colder out during the heating season, the boiler operates more. And there's a variety of control strategies that a multitude of manufacturers use. Some use a very simple, almost Excel-based reset curve. Others use a little bit more sophisticated curve. This one here, it's a cycle time curve, where basically, depending on how you control this, it will adjust the boiler operating temperatures based upon outdoor air and condensate return temperatures. So this has been around forever. Geez, I think probably 40 years or so. And most facilities have something like this in their space. And typically folks seem to think that you can't do much with these other than make sure they're working correctly. But the reality is you can. There's ways to make these better, and there's ways to install more efficient systems. And we're going to talk a bit about that. So as I mentioned, historically, there have been limited ways to expand the controls of these reset systems. Biggest thing was it's probably too expensive, right? Because if you think you have a big building, that building may be 100 years old, and you have a basic reset controller in there, the cost of running temperature sensors and wires throughout a building can be exorbitant. And if you factor in that building might be 100 years old, it might have asbestos, might have issues that really would impact the cost of implementing that quite a bit. It's really been prohibitive for customers to really look into that. So, and it kind of feeds into the logistic hurdles of doing it, as I mentioned. The good news is wireless sensors and competitive pricing have changed the market over the past 5 years. And what that allows you to do is when you put in these wireless sensors, the wireless sensors are now communicating with that reset controller to give another feedback to that system to say, okay, it's really warm up in these spaces. You don't need to operate the boiler as much as you are. Historically, they've never had that capability. So when you add that with the AI logic and factor in measuring outdoor air, you really can get a pretty sophisticated system pretty quickly installed at relative low cost. I was just looking at a customer in Brooklyn where they had a controller. The controller was a bit dated. It was about 25 years old. So they had it on their plan to they were going to replace it anyway. And our guidance to them was, hey, when you're replacing that, why don't you see if you can add in some wireless space sensors into that scope of work and allow you to have that constant feedback mechanism so it can adjust the controls based not only on the outdoor air temperature, but also upon the indoor space temperature as well throughout the building. So the cost of that system was relatively inexpensive. It was about $25,000 for, it was a 15-story high-rise apartment complex. And I think when you take that with the utility incentive that covered about half the cost, the customer's out of pocket was, I think in the $12,000 to $13,000 range, and their payback was about 6 months. So really a really big ticket item for relatively low cost that can really save you quite a bit, both now and in the future. Question I always come up when I do a steam system set point is, or steam system audit, excuse me, what should the set point be, Mike? And I always tell folks, well, you know what? Most steam systems operate, let me take a step back. Most steam systems that control space for space conditioning operate at relatively low pressure. And what does that mean? Relatively low pressure means less than 6 pounds, right? So typically that pressure is controlled via a pressure troll, and it's going to cut in and cut out points. But the fact of the matter is, when I visit sites, oftentimes the pressure is much higher than it should be. And the reason oftentimes, not all the time, but oftentimes is there's an issue. Someone's not getting the heat that they need. And the easiest thing to do is to crank up the pressure. Because most folks intuitively think that if you have more pressure, you're going to have greater flow. Well, it's actually the exact opposite. Less pressure equals greater flow. Typically, if you're increasing the steam pressure in a response to something in this that's wrong, there's something else wrong in the system that needs to be addressed. And what typically that is, could be a failed steam trap. Something could be airbound. You may have less than ideal venting. What does that mean? Twice in 2021, I remember going to customer sites with steam systems, and the venting was not working correctly because they had painted over the vents. Typically on a radiator, they paint the radiator a certain color, but they may paint over the vent itself. So think of a steam system as a living and breathing system where it heats up, evacuates the air, all those different things. And you need to have everything working correctly in order for the system to work correctly. And I always leave this with folks that increasing the pressure, just 1 PSI can oftentimes increase your fuel usage a 0.5 to 1%. So increase your steam pressure very cautiously, and think about why you're doing it and if there's something else within the system that needs to be addressed before you take that step. Okay, here's my little trivia, and hopefully everyone is going to get this one right. What's the operating steam pressure of the Empire State Building? And inevitably, folks seem to think that it's operating at a really high pressure. The reality is it operates at about 3 psi. It's got 6,500 feet of steam piping, I believe. Don't quote me on that. It's in that ballpark. And the reason it can operate at that low of a pressure, number one, it was designed that way. And number two, they have a vacuum system that allows the pressure to really operate at a very low setting. So this just kind of feeds into my previous guidance of increase the steam pressure very cautiously. You don't need to do that oftentimes. There may be something else that needs to be addressed before you do that. So just keep that in mind. Let's talk about improving boiler efficiency in a general sense, not just steam right now, but boilers. And I always use this slide. If your boiler looks like the picture on the left here, there's probably a way that you can improve the efficiency. Hopefully no one has those types of boilers anymore, but I actually have seen a few old coal boilers in the Northeast that have been retrofitted to either oil or gas, but the actual shell and body of the boiler was actually built into the building. So the logistics of actually replacing that are a nightmare. So, oftentimes it's just making the best they can with a tough situation. So if you want to know where to start and where to look and how, what would be the effect of replacing a boiler, your nameplate data on the boiler itself has a lot of great and useful information. Typical commercial building, they may have an old boiler. I was in a hospital 4 or 5 months ago that had a 95-year-old boiler, and it was extremely well maintained. They had no plans on replacing it, but it was still 95 years old. And all that information you can just gather right from the nameplate. So that'll help you inform you on where you're at for efficiency wise, ways you can improve, and ways you can incorporate potentially a capital plan to replace that boiler if you need to. Oftentimes folks may not have the ability to replace the boiler, but you can still replace the burner or add controls, right? We talked about heat reset controls and additional feedback loops to reset controls. You can incorporate something like that here. You can also put on a new burner. Burners often have very efficient technology add-ons that can be added into the scope. Typically, you can do fuel to air control servo motors. Old school burners have what's called jack shaft controls, where the fuel to air is controlled via jack shaft controls. And that's probably the most common system you'll see in the field, especially for older burners. But newer technology uses servo motors to control the fuel and air ratio going into the burning process, the combustion process. So what that allows you to do is really tighten up your operation, allow the burner to operate super efficiently, and really allow to put that boiler basically in cruise control to make sure that you're operating the most efficient way possible. Another great opportunity is heat recovery. And we're talking stack economizers in this slide. We'll talk about some other options in the next one. What I like about stack economizers, if you look at the cost that these typically are, they've gone down quite a bit over the years, and they're much more modular and easy to install. And you can, if your stack temperatures allow, you can recover that heat and use it in a variety of ways. This example here, we're talking about preheating boiler feed water, but you can also potentially use to preheat your combustion air, right? You can use it to preheat some other source that may have a need, right? So domestic hot water, variety of options that are available to you. And the good news is the market for stack economizers is pretty robust. There's a number of really, really good manufacturers out there that can either provide you a stack economizer as part of a new boiler package or as a true retrofit for an existing system. And again, the cost add-on, although it can be expensive in some instances, it's not as much as what it used to be. So it's always something to think about if you have the need or the opportunity. One of my favorite topics to talk to customers about is insulation, because inevitably, when I go into a boiler room, I talk to the customer about insulation. And usually the customer will say, well, everything's insulated, we're good. We don't need to look at anything right now. And inevitably what I find is situations like this. The picture on the left is a valve, and if you can read closely enough, it's actually in Celsius, it's not in Fahrenheit. But that valve is uninsulated. And there's a variety of thermal blanket insulation packages in the marketplace there that could offer that not only energy savings by insulating that valve, but inevitably when you insulate something that's really hot, you're solving not only an energy problem, but a life safety issue problem as well. So I can't tell you how many sites I've been to over the past year or so where the insulation opportunities were much greater than what the building owner thought. And, oftentimes insulation can be out of sight, out of mind, but just taking some time to look at what you have in your mechanical spaces and building and developing a plan to insulate things that need to be insulated solves a variety of problems for you. And the problems are not just energy related. Typically if you insulate something, you're going to stop it from potentially sweating, so no leaking. If someone were to touch something really hot, they don't have that issue anymore because it's insulated. So you're solving a lot of problems, not just on the insulation themselves. So I'll use the example here. This particular customer, if you look at the picture on the right, most of the insulation there is pretty new and well maintained, but we did find a lot of valves, fittings, a lot of OS and Y valves, big OS and Y valves that could use some insulation. And the net effect was it's saving them about $6,000 a year. I think they're out of pocket after the utility incentive was about $4,000-ish. So, your payback was relatively quick. So this was a great project at relatively low cost and a great return to the customer. But the feedback I did get from this customer was interesting in that they said, Mike, I'm really pleased with the energy savings, but I'm more pleased with my staff not burning themselves on incidentally touching a valve. So some great opportunities, like I said, not just on the energy savings side. So just to wrap up on heat recovery, there's a variety of ways you can recover heat. We talked earlier about ventilation, wheel heat recovery, and there's a variety of vertical segments where these work well in hospitals, athletic centers, labs, hotels, you name it. I have seen a number of customers over the past year look at drain water heat recovery, and there's a variety of technologies that can do that. You really need to have a constant load that you can recover heat from. So those typically work well in restaurants where there's a lot of hot water going down the drain, or hotel or something along those lines. A lot of facilities that might use any type of sterilization devices. Hospitals have those that may have a lot of hot water going down the drain. You really got to find the right fit for that type of project to work. On the steam plant, you have a variety of things that you can recover from your flash steam on steam boiler blowdown. Most steam boilers, not most, all steam boilers need to manage the water chemistry really well in a boiler to have it operate correctly and efficiently. And typically what you do is you're blowing down some of that water within the boiler on a schedule, some preset schedule, and recovering that heat from that boiler blowdown and using it for something else is a great way to improve the efficiency. Fourth one down, a variety of industrial processes that you can recover heat from. A lot of customers are using simultaneous heating and cooling for different batch processes. A lot of pharma companies have ways where they're making their product, and there could be a way to recover some of that heat that they're using. A lot of pharma companies that make product in big kettles, steam kettles. There's great ways to recover a lot of heat from that. And then lastly, wastewater treatment plants. Sometimes your effluent water, you can use water sort heat pumps to recover some of that heat and use that for something else. I always encourage folks, just keep an open mind and most of you will know where there's potential opportunities to recover some heat. And always, reach out to your trusted engineer or trusted mechanical contractor to potentially help you work that scope out a bit. And then with that, I'm going to transfer back to Mark. And Mark's going to talk a bit about National Grid's incentives.
Thank you, Michael. So I guess the first thing I would like to point out is the fact that if you can save natural gas in most utilities, there's an incentive out there. So don't get hung up on the different technologies or the different programs that I'm presenting. I just want to touch on a few of the ones that we commonly see. And although the values that you might see here in terms of the rate of the incentive or the incentive itself, these are specific to National Grid currently, but we all talk amongst utilities, and if one utility comes upon a program that's very successful, it won't be long before other utilities copy that, and it's not a competition. We want to see every utility help their customers save money. So just those two important things that I'd like to point out. So first of all, I want to point out that whatever I'm touching on here is available with information at rebatesee.com. All of our gas rebates are, there's applications there, as well as descriptions of the program itself. So that's one important thing. The other thing is the fact that there are two different types of rebates really, or programs available through most utility companies. Some are prescriptive and some are custom. So prescriptive programs essentially pay out based on the size of the equipment. Oftentimes, for example, we have space heating and water heating equipment that pay out based on the MBTU of or MBH of that equipment. As an example, right here we're saying up to $9,000. That is our program for a 3,000 MBH condensing type boiler, so a high efficiency boiler. We pay out based on the size, but we max out for the 3,000 MBH boiler at $9,000. That is a significant sum towards the cost of that boiler. We also have indirect water heating, depending on the size of the storage and the size of the burner, that range from $100 to $300 for indirect heaters. And then we also have ones for, on demand or in demand hot water heaters, $400 or $500, depending on that particular type of equipment and the input. We have programs for, Mike pointed out, Wi-Fi thermostats, to be used in some building automation systems. We have a program that pays, for those Wi-Fi stats, $75 per stat, up to a limit of 10 for some buildings where you might see that. And then $110 for single stage reset control, $190 for multi-stage reset control as well. I do not have control of, Mike, if you could advance it, that'd be great. Oh, back one. There we go. So as I'd mentioned, we have prescriptive programs. They cover all forms of things. Steam traps, we'll get into that a little bit here on the next slide. Thermostatic radiator valves. And we have programs with kitchen equipment vendors as well. So in addition to the prescriptive, we have the custom. That's pretty much everything else. Like I said, if you can save gas, we have an incentive for that program, most likely. That would cover heat recovery systems, such as the ones that Mike had described, energy management systems. We actually have a program that pays out per point for the energy management system. So it sounds prescriptive, but we have to do what is referred to as screen it for the benefit cost ratio. So it's not completely prescriptive, but it pays out as if it was. So we pay $250, up to $250 for a point that you put or program into your energy management system. The commercial kitchen, there are custom programs with that as well. We see a lot of kitchen hood controls and makeup air units. They can get very large in commercial restaurant applications or larger school districts. We see quite a few of those there, where we're actually putting in some cases, both temperature and particulate sensors to ramp up the exhaust, ramp it up or down based on the actual need. So it's more of a demand kitchen hood control, or any kind of hood control can be in a laboratory as well. We have quite a few insulation programs. We've been seeing a lot of roof insulation projects lately. Quite commonly, they're very hard to get to pass our benefit to cost analysis, because whenever I ask for a cost of the roofing project, I get the whole cost. I'll get the demolition, the ballast removal, a lot of parapet repairs or things like that need to be done to the roof. When in actuality, what we want to screen is the cost of the insulation itself and the labor to lay it in place, not the cost of the roof or the roofing project itself. We have a lot of piping insulation, as well as wall, both fiberglass, foam, and cellulose as well. Like I said, any proven technology that saves gas has a good payback. It may be eligible for incentive. In fact, I almost guarantee it is. Next slide, please. So one of the things that I know Mike, whenever he goes into a steam building, he's most definitely going to come up with a steam trap program. And my rule of thumb is that if somebody asks you where your last survey is, your steam trap survey, if you can't turn right around and immediately grab onto it, or where that survey is in your electronic file, it's probably been too long, because steam traps are fairly prone to failure. Say that one fast, Mike. Generally within 5 years, if you haven't done anything to that steam trap, it's probably in some failure mode or another. So we do have several types of programs for steam trap repairs that I want to really touch on because of its importance here. We have, first of all, 50% of the steam trap survey for the maximum cost of that survey, up to $7,000. We'll pay that automatically. Then the other 50%, depending on whether you want to use our prescriptive program or our custom program, as long as you repair your steam traps that are failed, we will reimburse the other 50%, as I said, up to a maximum cost of $7,000 for the survey. So once you've got the survey done, then you can decide whether you want to go prescriptive or you want to go custom. We have a prescriptive program that pays $75 per trap, with a limit of 250 traps per facility per year. And that really is, it's for repairing or replacing the steam trap. Most major trap manufacturers, they have the assemblies all ready so that you can take the bonnet off of the steam trap and drop the new inserts in it, clean it out, and it should be good to go. The other ones are for the custom incentives. So we're paying currently up to $1 per therm, and that's the amount of gas that you save on an annual basis by replacing or repairing that steam trap. And we'll pay up to 50% of the cost of that project based on the therms. So will pay $1 per therm up to 50% of that project cost for the steam trap repair or replacement. So pretty much it's leaving you with a balance of a project that I rarely see that does not pay for itself within a year, once we're done with the incentive program. So probably the most important thing that you can look at if you have a steam system is your traps. And I think Mike will agree, because I don't know as though he's done a treasure hunt for National Grid in the last year or so that hasn't come up with recommendations to look at your steam traps. Next slide, please. Do I have control yet? Okay. So again, here's our contact information. That concludes our presentation. We're going to open it up for question and answer, but a few of the important website, in addition to the rebatesee.com, here are our website. So I'm going to leave that. I'm going to put it on mute.
Wonderful. Well, thank you very much, Mike and Mark, for some great information. As they mentioned, we do have some time for some questions from the audience, and we've got plenty that have been coming in throughout your presentations. So, Mike, I think some of these are at the beginning are more for you. One of our attendees had a question on ECMs turning off CVD during COVID concerns and impact on energy costs. I think you touched on that briefly, but anything else you want to mention about turning off CDV during COVID?
Yeah, so I think there might be a typo on their part. It's supposed to be DCV, so demand control ventilation.
I was gonna mention that.
So for those that don't know, demand control ventilation, basically you control your ventilation based on the demand, right? So demand is typically measured by CO2. So as you have more people within a space that are exhaling, they're increasing the CO2 levels, you're bringing in your more outdoor air in response to that. And then conversely, as the building or space becomes less occupied, you can reduce the amount of outdoor air that you need accordingly. I generally speaking, there's always that caveat or unique situation that arises that I would not disconnect your demand control ventilation without giving it a lot of thought. If you have a situation where you have a lot of people occupying a space, obviously you want to bring in the maximum amount of outdoor air that you need. So I, generally speaking, wouldn't disconnect that without giving it some thought, but encourage you to really, number one, explore that, make sure it's working correctly and making sure it's responding to the needs that you have for that facility.
Yeah, a comment on that as well. We did, once COVID hit and it was mandated that we needed to, or recommended in a lot of cases, that we reduce occupancy within a building, then all of a sudden we started getting incentive applications for demand control ventilation, because they felt that because they were reducing the occupancy, they could reduce the ventilation, which is really defeating the purpose of reducing the occupancy. Ashrae bases a lot of their code, most of their code, on the amount of outside air or, CFM of ventilation per person. So, our CDC and Ashrae said, well, let's reduce the occupancy of the building. So in a way that's increasing the ventilation per person and making the space safer. So we didn't want to see projects come through that we're recommending then reducing the ventilation, because it's defeating the purpose. So those projects are on hold. It's not that we don't we don't encourage ventilation control. It's that just now's not the time to do it. And if you're going to do it, as Mike said, do it very cautiously.
Perfect. Thank you. Our next question was, someone saw an active desiccant during slide 28. I believe that was the model of, looked like a store. They were just asking, how often does that need to be refreshed?
Great question. More often than you may think. I would always defer back to the manufacturer's recommendations and make sure that you're working with your manufacturer and your local maintenance contractor to factor that into both the maintenance and capital planning for that system.
Yeah, most manufacturers have sensors that monitor the amount of moisture within your desiccant and can be set to automatically trigger the regen, or part of the process where it actually heats it up and gets rid of the moisture from the desiccant before it comes back around again. So a good question, how often? It's manufacturers typically have that set up so that you're not doing it manually. But also important to point out the fact that you don't necessarily need to use natural gas or electric heat to regenerate either. We see projects come through where they're using heat off of a compressor, for example, to help regenerate the desiccant dryer. So look for other sources of heat.
Perfect. We did get a few questions regarding wireless sensors. The first one I'm going to read is, how does the premium for wireless sensors offset the payback? That's one of the questions.
Say that question again, Amy.
They're asking about the premium cost. I think the upfront cost of wireless.
Oh, premium. I'm sorry. Okay, yeah. So great question. If you had asked me that question a number of 4 or 5 years ago, I would have told you that's pretty expensive. The good news is wireless sensor costs have come down quite a bit when if the ancillary pieces of equipment that you may need for that, repeaters and whatnot, to make sure you have a good signal, that cost is gotten quite reduced as well. So what I like about the wireless sensor market is the real takeaway is most folks have some sort of boiler reset control already, and that boiler reset's responding to outdoor air, return water, or condensate return temperatures, and making some determinations for that. But it never knows what's going on truly within the space itself. When you add in these wireless sensors into the space, into the hallways, the apartments, whatever that is, you're giving another level of feedback to the controller so it can make better intuitive or iterative adjustments to the boiler operation. So it's really relatively inexpensive solution with great benefit and quick payback.
Yeah, and certainly you're saving the wiring cost. Some systems might need repeaters to boost that signal. And I will point out that you actually, should, before you go all in for wireless sensors, want to make sure that your building is, capable of doing that. You have computer rooms that might be lined for radio frequency and things like that, but you might want to have them come through and do a survey first of all to make sure that where you're putting the wireless sensors are actually going to be able to get the signal down to the controller.
Great point.
Perfect. And then someone else, Mike, was asking, the wireless gain of 6 months you highlighted, was that mostly on run schedule gains?
Yeah, the 6 month return, so what the inevitable reality that we see often is the controller that the boiler is being controlled by, whether it's a reset controller, a more sophisticated building management system, or anything along those lines, may or may not be touched very often, right? So it may be kind of in a set it or forget it mode, and the staff may not want to touch the reset controller too much because they may not have a lot of training on it. So each situation is a little different. That particular situation was the runtime on the system was reduced dramatically because no one really had touched the reset controller in a number of years. And the net effect of that was huge amount of reduced runtime, quick return for that customer.
Perfect. Someone else was just giving their input. They said they have had success with the sensor technology, but they also did an installation review before they put in that, and that helped kind of get some efficiency before they put in those sensors as well.
Absolutely, absolutely.
Mark, this question is for you. Can you talk a little bit about your service area? Somebody was asking if National Grid extended its DSM rebates into Western New York.
It's very hit or miss. I actually had I was going to include a map of New York and our project area, but we were getting concerned about time on this. So we opted not to show it, but we do not have gas in the Buffalo area. There's hit or miss spots between Rochester and Buffalo and around Rochester. Of course, Rochester Gas and Electric, covers most of the greater Rochester area, but areas around, if you'd like, I can provide our map, after this presentation. I'm sure we can include that or provide it.
Perfect. And Mark, maybe some tips on if somebody is interested in activating their rebates and things like that. Where do you start with that website that you showed? Is that the best place to kind of start the process?
Yeah, rebatesee.com, or better yet, you should have a sales rep in your area. If you know who that is, go directly through them. But if you go to Rebates EE, they will have information on the programs as well as the applications available for you.
Perfect. Another question here, is there a standard pipe installation recommended for commercial HVAC projects?
Well, I rarely see more insulation than what is required by code. So if it's new construction or rehab, I don't typically see incentive requirements or incentive applications for those, because people just don't exceed code often. And there's actually a diminishing return on doing that. The one thing that Mike touched on were the replaceable covers for valves and fittings. I would say that is excellent technology. There's several vendors that we work with in the area, but they have a very good return after the incentive. They are expensive, don't choke when you first see the cost of it, but they're very effective. And I can say that if you go into your boiler room or your heating plant and it's uncomfortably warm, you should do some investigation and find out why that is, because there's something that's not insulated that probably can be. Typically, when your boiler room or your heating plant's too hot, what do? We open that louver in the roof, turn on the exhaust fan, and let it go. We don't want to see that. We want to see the heat that you're creating, the steam, hot water, whatever, get to the terminal unit that it's intended for. So 2 points. If it's too hot, find out why.
Perfect. And then another question, Mark, are there any incentives for upgrading older systems to a building management system or a building automation system?
Excellent question. Yes, primarily because we see an awful lot of EMS systems out there that are 25, 30 years old. They're pneumatic type controls, and people can't get parts for them anymore. So we do include that now in our program. In fact, I'll say if we can verify or validate the fact that your EMS system is not working properly because something's outdated, I don't want to open a big bird's nest here, but if we can prove that it's not working, we'll help you fix it. It's very important to have that functional.
Perfect. We'll give it just another minute for any other questions that came in, but Mark and Mike, thank you very much. Any last thoughts on either of your sides with the audience, for the audience today?
Nope, I always tell folks it doesn't hurt to look around a bit. And just as Mark mentioned, if something's hotter than it should be, if you're uncomfortable in a room, poke around and see what's going on. Doesn't hurt a little bit.
Perfect. Mark, any last thoughts for you?
I'm good.
All right.
I have a dog that's nudging me, that's telling me it's time to go outside. So.
Well, wonderful. Well, thank you very much, both of you, for being here. Thank you for National Grid for sponsoring this webcast. Again, you'll receive a copy of the slides. Oh, looks like there might be one more that came in.
That's fine.
Oh, not a question. But when repairing damaged insulation and installing removable pads, airing, and reducing greenhouse emissions. So that aids in reducing greenhouse emissions. So that's
Absolutely.
Absolutely.
perfect. Well, thank you again. Just a reminder, you'll receive your follow-up email with a copy of the slides and your link for your CEU certificate. And we thank you again for being here. We look forward to seeing you on our next FacilityNet webcast. Have a great day, everyone.